Welcome to the first of the videos on dynamic memory allocation. This is a motivational exercise in which I talk about a population of rabbits. Could be a population of students. The code is very similar to that which we saw earlier in the course. Here's the motivating example. Simulation of a community of rabbits. So we have what's called a time-based simulation in which we have a loop, carries on forever, incrementing the current simulation time by delta t each time through the loop. Each time through the loop we work out how many rabbits are born, and we go through and construct that many rabbit objects, rabbit records as I've called them here, and add them to the population, and we do something similar for dying rabbits. Notice in each case we need a birth rate and a death rate, sort of death probability there, to work out how many in each interval of time should be added and removed. And the question now is, how do we go about constructing a new rabbit record and destroying rabbits? So let's move on to the next slide. Here's the solution. Now this is a longish piece of code. It goes on for 2 slides there. I'm certainly not going to develop this on the fly. I'm just going to explain it briefly and give you some figures showing what it's all about. So this is the idea that I introduced in Struct Example 3, where we had a pool of students. Here they're called rabbits. So I have a variable here called rabbit pool, which has a certain maximum number of rabbits. And a new thing that we didn't have in students is a variable free rabbits, which is a linked list of all the available rabbits. Before I just took them one by one out of the pool. Now I'm going to put them in a list. The benefit of a list being that I can also put rabbits back on this list as they die. So it begins with a type def, exactly as we had with student. We've got the pool, and we've got this new rabbit pointer thingy. I've got an initialization loop here, which goes around and links every record in the pool to its next one, and then points the free rabbits variable, that's that one, at the first in the list. So to explain what that's doing, that creates this situation. Here's the rabbit pool. In this case, there's only 6 rabbits. One of them appears to have gone nameless. That's just a bug. 6 rabbits. Each one has its next pointer pointing to the next entry in the array. This is not always going to be the case. It will point to the next entry in the array, as you'll see later. That's just how we start. And I have a free rabbits variable, which is a pointer to the first one in this linked list of rabbits, terminating with a rabbit who has a next pointer of 0. So that's the situation that is created by the rabbit initialization call. That's this one here. You can look through the code if you like. If I skip ahead to the main function, it looks like the following. I create 3 rabbits, 1, 2, and 3, and then so these are sort of in a population, if you like. I haven't bothered doing anything with them, like linking them or anything like that. I've just created 3 rabbits, and then I've freed 1 rabbit. The point of this being, I wanted to show you what the linked list looks like, the free list looks like, as we go through those steps. Again, the new rabbit code and the free rabbit code. New rabbit does the same sort of stuff you saw as done by students, so I won't go through that. The free rabbit is the new bit, and this just sets the particular rabbit pointer that we were given. It sets its next field to point to the current head of the list, free rabbits being the head of the list, and then it sets the head of the list to point to this newly freed rabbit. What this is doing is putting the freed rabbit on the head of the list, just as we added students in at the head of a list of students in Struct Example 3 as an exercise for you in the lab. So let's look at what's happening to the data structures here. Incidentally, these are generated by DDD with me adding in the actual pointers. So here are the 3 rabbit records, rabbits 1, 2, and 3. I've got a free rabbits pointer. So when we first of all call for a new rabbit, we take the first item off the free list and we point this at it. Then the free list moves to point to the second one, and so on. So after 3 of them, the free rabbits pointer is pointing at the 4th record, 1 origin, 4th record, 1, 2, 3, 4, and the linked list now has those 3 rabbits in it because the first 3 have been taken off the list and are pointed at by rabbits 1, 2, and 3. Then what we had in the code, as you may recall, was a call to free the second rabbit. So let's look at what that does to our free list. We're about to, actually I'll back up, we're about to free this rabbit. That's the second rabbit in the list. In order to free it, and you may want to stop and look at what the code does again, in order to free it, we're going to point the free rabbits pointer at that rabbit and link it to what free rabbits used to point at. So that gives us this structure here. So free rabbits points at the newly freed rabbit, which is rabbit 2, and that points in turn at what used to be the list of free elements. So we've now got 4 rabbits on our free list, and they're in a linked list. Notice we still have a pointer in rabbit 2 pointing to this rabbit, but it would be really bad idea to use that, because if we inadvertently make a bug in our code and reuse this rabbit pointer, it's going to get released again as the head of the linked list. It's going to be the first one that's reused by the next new rabbit call, which means we would then have aliasing. We'd have 2 rabbits referring to the same actual rabbit record, and things would get ugly. So one of the issues here when you're dealing with dynamic memory is that you must make sure that once you've freed a record, you don't try using it again. So the big takeaway here is this idea that I have what is called a single entity dynamic memory system. So the rabbit pool provides you with a record when you ask for it, a rabbit record, and you can pass them back into the pool when needed. And the pool is actually managed via a linked list. And this is very efficient, but it's only working for rabbits. And as we will look in the next video, what about a more general solution when we have a whole lot of different entities? So that was the motivation, and it introduces a few concepts. Thanks for watching. Bye.